Okay. All right, so you guys, when there's one, obviously if there's no toothpicks, there'll be no squares. If there's one toothpick on the side, how many squares do you see? One. If there are two toothpicks on the side, how many squares do you see here? Four. And so when there's three, how many squares? Nine. Okay, and then if you draw the fourth one, which would be what? 4 by 4, won't it? Okay, when there's four toothpicks on the side, there'll be how many squares? 16. Okay, now there's a couple different patterns you got to see here. You need to see both patterns. The first pattern I want you to see focuses only on this. So don't even look at this. Just what's the pattern as you go from 0 to 1, 1 to 4, 4 to 9? What's the pattern each time? What's happening? Well, here you go up by what? 1. Here you go up by
3.
Here you go up by
5.
7. So each time you're going up by 2 more than you did the previous time, right? Isn't that the pattern?
Yeah.
Yes or no? Brett, does this make sense? That each time you're going up by 2 more than you did the last time? Okay. All right, so you go up by 2 more each time. That's how I wrote it. You go up by 2 more. You go up by 2 more. Sorry about my sloppy writing there, but you go up by 2 more each time. That's the pattern that I wanted you to see. Now I want you to see a different pattern. By the way, not yet. Okay, so use that pattern to predict the one that would have 5 on the side. Guys, what would you have to do to get the next number here? If you went one more spot here. The next time you'd have to add what? 9, and so it'd give you what?
I did it completely different.
It'd give you what? I know, but you're going to do it that way in a minute. So what would you get?
25.
25. Everybody, hold on, don't say it yet.
I did get 25.
The pattern was that you go by up 2 more each time. So here you went up by 5, then you went up by 7, so the next time you got to go up by 9.
If you were to add 9 to 16.
That was how you get 25. 9 plus 16. All right, that's one way to get it. Now I want you to see a different way to get it by coming up with an equation. In other words, if I call these x values and I call these the y values, how would you get the y values from the x value? What's the formula? Who has it? Raise your hand. Go ahead. Y equals what? X squared. Does everybody agree that that would work? If x is number of toothpicks on one side and y is the number of squares, to get the number of squares, you would take the x and square it. Doesn't that work? Let's check it. What's 0 squared? 0. What's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 9. Doesn't that work? Yes? Okay. And so we're going to be doing all this today in the lesson, but I tried to give you an activity where you could see it visually with the toothpicks, okay? But this is what we're going to be doing today. All right, now, and the answer here is obviously yes. I just checked it and it worked. Okay, now, so then how would I figure out the number of squares y for 9 toothpicks on the side? You would plug in what? 9 for what? X. And so you'd get 9 squared, which is obviously what? 81 squares. Got it, guys? Okay, good. All right, let's do the lesson now. Well, I did it, so probably not. What is that? One lesson. Then I'll explain what's happening next week.
What's next week?
I'll explain.
IB week coming up soon.
What?
Do we have that IB thing next week?
No.
Yeah, I got you.
What do you mean? That's not what I'm talking about, though. In seminar, what? Huh? Not sure. That's not what I was talking about, though. Pass those back, please.
Don't crack my bed.
369.
I'll punch you. Mr. Simber, you're going to collect the homework?
I might, yeah. You guys, did I give you back the IB stuff?
No, not yet.
I didn't?
No.
Remind me to do that later in the hour. I thought I did. No?
I put it in on the computer, but you didn't.
Okay. Remind me to turn it back to you guys later. All right. Does everybody have a note packet? You have enough back there? Okay. Here we go. Okay, again, this lesson isn't too bad if you pay attention. If you don't, again, just like anything else, you're going to get lost. So please watch. Okay. We've got to make sure we understand the difference between what we're doing today and what we did in the past, because I'm going to make you do all three of them on the next test. So, in the activity, we discovered that with a quadratic function, wasn't y equals x squared quadratic? Wasn't it? The differences in the y values changed by the same amount. In other words, they had the what? A common what? Second difference, right? The differences of the differences were the same. Okay, so you guys, this first column here is nothing new. When you have a linear situation, which graphically is obviously a line, let's see what that looks like when we study the table of values. Well, first of all, you got to make sure you have a consistent change in x before you can look for a pattern with the y, which obviously we do. Okay, so with a linear situation, what's the pattern? You have a what? You have a what? What's happening to the y values? You have a what? The same difference, right? A common difference, and that's how you know by looking at a table that it's going to be linear. Is that clear, guys? Okay, so that's nothing new. And then later on in first semester, we talked about exponential graphs, which look like that. And by the way, their equations look like that. And in a table, again, what's the pattern with the y values? What was the pattern? How do you get from there to there, or there to there, or there to there? What's the pattern? Each time you're doing what? You're multiplying by 2, which means the y values have a common ratio. Is that clear? Okay, so that and that is what you did first semester. Okay, we studied linear equations first semester. We studied exponential. This is what's new today. But again, on the next test, I'm going to make you do all three of these. So just so you know. Okay, so this is what's new. With a quadratic, which again has y and an x squared, isn't that what makes it quadratic? Yes, sir. Okay. Obviously, the graph is a parabola. But if we pick some points off the graph, or get the points from the equation and put them in a table, let's study the pattern. What's the pattern for a quadratic situation? Well, after you have a common change in x, what's the pattern with the y? Well, this is tricky. Everybody look up here. You're not going to be able to do this on your own. Look up here right now, everybody. Put yourself at -1 on the number line, and then tell me, how do you get to -2? You subtract 1. Isn't that how you get from -1 to -2 on the number line? Okay, now put yourself at -2 on the number line. How do you get to -1 on the number line? You add 1. Okay, now put yourself at -1 on the number line. How do you get to 2 on the number line? You add 3. Put yourself at 2 on the number line. How do you get from 2 to 7? Add 5. Okay, now there's no pattern there, is there? Is there a pattern there? No. Okay, so now watch what's going to happen. How do you get from -1 to +1 on the number line? You add 2. How do you get from +1 to +3 on the number line? You add 2. How do you get from +3 to +5 on the number line? You add 2. So you guys, there you go. That's going to be the pattern for a quadratic situation, when the differences of the differences are the same. Isn't that what I did? I took the differences, then I took the differences again. That's why I call it a common what? Second difference. In other words, the differences of the differences are the same. Does that make sense? Okay, so now on the next test, I'll tell you right now, you've got about 30 questions on the next test. About 6 or 7 of them at least are going to be, here's a table, tell me what kind of situation it is. So you have to either tell me what? Linear, quadratic, or exponential. And so you'll have to look at the patterns in the y values. Is that clear? Yes? Okay, so let's do a bunch of examples now. Here it goes. Ready? Heads up. All right, one way to tell is just by graphing. Okay, so what I'm going to do is I'm going to tell you, for these ordered pairs, is that linear, Is it exponential or is it quadratic? So one way to do it is just by graphing and looking at it. Okay, so 4 comma 4 is here. Everybody agree? Yes?
Yeah.
2 comma 0 is here. Just plot the points with me, guys. Everybody should be doing this. Then you got 0 comma 0. You got 1 comma negative a half. You've got negative 2 comma 4. Okay, and so what type of graph do those look like they're forming to you?
Second.
Yeah, it is nonlinear, but specifically it looks like a what? Looks like a parabola, doesn't it? Everybody agree? Yes?
Yeah.
So what type is it then?
Quadratic.
Quadratic. Write it down. Good.
Oh,
Okay, but you see what we're doing? So this is one way to tell. Now this is going to be very time consuming sometimes, so this is not the way we're always going to do it, but this is definitely one way we can do it. Okay, let's do another one. 0, 1 is here. 2, 4 is here. 4, 7, let's see, 1, 2, 3, 4, 5, 6, 7 is there. Negative 2 is here. And negative 4, negative 5 is here. Okay. What kind of graph do those look like they're forming? Linear. All right, because the graph's a line. Everybody agree? Okay. Okay, so obviously that's linear, just by looking at the graph, right? All right. Okay, ready to do the third one, guys? Okay, let's do it. 0 comma 2 is, you should be doing it. Oh, aren't you writing it down? You should be doing it. 0 comma 2 is here. 2 comma 8, let's see, 1, 2, 3, 4, 5, 6, 7, 8 is there. 1 comma 4 is here. Negative 2 comma half is here. And negative 1 comma 1 is here. So what kind of graph does this look like it's forming, guys? Exponential. Right? That definitely looks like it's exponential, right? Okay, so you can definitely tell graphically the difference between the three, right?
right.
Okay, so any questions before I turn the page? Okay, next page. And again, they look long because I only put like one problem on each page, but it's going to go somewhat quickly. All right, now, you guys take a look at this. I don't want this to confuse you, so I'm just going to say something very briefly about it. But I'm not sure how much it's going to affect the rest of the lesson, but it's just something I want to point out. In a few minutes, we'll be writing equations. Okay, now sometimes what's going to happen is when you get in an equation and for like an exponential and you graph it, it might fit the points like that. In other words, it might not quite go through all the points. But then if you take the points and you make a quadratic equation out of it and graph the parabola and just look at the piece of the parabola, it's going to be a better fit. So what I'm saying is this. When the answer might be exponential, you should also check what? Quadratic. Because sometimes a piece of the parabola will fit better than the entire exponential function through the points. Does that make sense? All right, again, that's not a big deal. I think this is more going to matter if I eventually show you how to do this on the calculator, which I'm not sure I'm going to have time to do. So that'll be more important in that lesson, but I did want to point it out while we were on the topic. Okay, but anyway, that's not something that's going to bother us the rest of the examples. So let's just move on. All right, what does it say? Read the directions, Brendan. What does it say?
The tall end of the table of values represents a linear, an exponential, or quadratic.
Okay, so instead of graphing, it's going to be much easier just to look at them and look for a pattern. Ready, Brett? Got a pencil? Okay, so here we go. So instead of making a graph like I did in example 1, let's just see if we can find a pattern. All right, but you guys, I want to warn you. Always start with the x values. Make sure there's a consistent change in the x's, because if there's not, then you're not going to be able to look for a pattern with the y values. It's going to be too difficult. So as long as there's a consistent change in x, it's safe to go ahead and look for a pattern with the y value. So what's the pattern? Is there something I could multiply each one of these by to get the next y value? No. What is the pattern? Subtract 3. Does that work every time? Okay. So what does that mean? We have a what?
Linear.
Well, wait. We have a common
Different.
first difference, yes?
Agreed.
Okay. And so if you have a common first difference in the y values, we know that will always turn into what type of a graph? Linear. Yes. Everybody agree? Yes or no?
Yes.
Okay. All right. Next one. First, look at the x's. What's happening from one x to the next? Jessica, what's happening? Each time you're what? Adding one? All right. So all that means is, since you have a consistent change in x, it's okay to look for a pattern with the y value. So is there a pattern to get from here to here, here to here, here to here? What's the pattern? You're what? Well, here you're adding 2, then you're adding what? 6, then you're adding 8. I don't really see that type of pattern. You times it by what? 3. Does that work every time? Yes, it does. Everybody agree? If you keep multiplying by 3, you'll always get the next y value? And so that means there's a what? Common, what do we call that? A common ratio between the y values. And therefore, what type of relationship would this be? Exponential, yes? Okay. All right, I want everybody to do C and D. Go, 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 go. Do it. Everybody do C and D. Write the pattern. Don't just do it graphically. Write the pattern. Okay, then you check the differences of the differences. See if you see a pattern there. Okay, check the differences of the differences. You guys, if there's no common ratio and there's no common difference, what's the next thing you look for? The second difference. Yeah, so you look at the differences of the differences in that case. See what that shows you. Done, Tommy? Okay, you got to stay focused, okay? You didn't write these down. Hurry up and write them down before it's too late, because you're not going to have good notes to look at. Oh, we're not there yet. You got to wait. You got to wait. You got to wait. I'm going to tell Chantel she lost a point. I should, how about this one? I should tell Chantel she'll lose a point. Even better. Yes? No pattern? Still looking? Well, write it down. Otherwise, you're not going to be able to ever see one if you don't write something down. Remember, you got to take a risk. That's what IB learners do. They take risks. They don't wait for me to explain it. You better. Or you're taking a risk on your cooperation grade. I know. All right. Okay. Are you ready? Okay. You guys, first of all, with the x's, what do you notice? It's the same change every time, right? You're adding 1. All right. All that means is it's safe to go ahead and look for a pattern with the y's. So, Jessica, is there something I can multiply each time by to get the next y value? No. All right, so then we got to look at the differences. If you're at 0 on the number line, how do you get to -1? If you're at 0 on the number line's back there. How do you get to -1? Yeah, you -1. Now, put yourself at -1 on the number line. How do you get to +2? You add 3. Okay, put yourself at 2 on the number line. How do I get to 9? You add 7. If you're at 9, how do you get to 20? You add 11. Now, clearly there's no common difference there. So now I'm going to look at the difference of those differences. In other words, I'm going to look at the second difference. Yes? Yeah. Okay, how do I get from here to here on the number line? If you're at -1 on the number line, how do you get to +3? You add 4. If you're at 3 on the number line, how do you get to 7? You add 4. Same thing here. You add 4. So what does that mean? We have a common second difference, which means it's what type of relationship? What type of relationship is there between x and y? Quadratic. Very good. Okay? All right, Tommy, you can help me with this one. Do you notice each time we're adding 1? So that just means it's safe to look for a pattern with the y values, okay? All right, so is there anything I can multiply by to get from here to here and here to here and here to here consistently? No. All right, so now we're going to look at the differences. So Tommy, if you're at 3 on the number line and you go to -3, how do you do that? You what? You subtract 6. Good. And if you're at -3 on the number line, how do you get to -5 on the number line? Subtract 2. And then here, how do you get from -5 on the number line back up to -3? You add 2. Good. And how do you get from -3 to 3? You what? Add 6. Now again, doesn't look like there's a pattern there. So what I want you to do now is check the differences of the differences. So, Tommy, you can continue. If you're at -6 on the number line, how do you get up to -2? You what? Add 4. How about from -2 to +2? You got to what? Add 4. And same thing here. So again, you guys, do you agree you have a common second difference again? So what type is it then? Let me write that down.
It's a quadratic.
Tommy, what kind?
Oh, crap.
What is it? Quadratic. Common second difference again. So it is quadratic. Okay, you guys got it or not?
Yeah.
Yeah, I think we got it.
Okay, now we're going to take it a step further. Yes. Shh. Well, I wouldn't ever say it's obvious because these can be tricky. I'd like you to show the work if that's what you're asking me. Yes. Okay, thanks.
What if there's no first difference? Can we just assume that there's a second?
No, because it could be none of these 3. I could give you a table that has none of these 3 relationships, right? So you do got to check. Maybe that was your question? Yeah, because there could be a fourth situation where it's not none of these 3. And then you're going to be out of luck if you guess that it's going to be a common second difference, right? Anyway. All right, so now watch. We're going to go a step further. Not only are we going to identify the type, in part B, we're going to write the what? Write the what? Equation. You guys ready? And that's the challenging part. So let me, shh, guys, please stop this chatter. Please. Okay? All right, so, all right, who am I going to call on here? How about Zach?
Which one?
Zach P. Okay, Zach P. First of all, notice with me that there's a common change of 2 in the x's, yes? And all that means is it's safe to go ahead and look for a pattern with the y value. So do you see any pattern to get me from here to here, or here to here, or here to here right away? Do you see any direct pattern? Like, would you add the same amount every time? How about would you multiply by a number every time? No. Okay, so then what am I going to do? I'm going to look for the what? Look for what, Zach? The what? Maybe the common second difference? All right, let's find the first difference first. Okay, so Zach, how do I get from 0 to 1? I what? How about from 1 to 4? Next one. Next one. Okay, now obviously that's not a common first difference, but let's look at the differences of those differences. How do I get from there to there? How do we get from there to there? How do we get from there to there? All right, there you go. We have a what? Common second difference. Don't go anywhere yet. This is the most important time for you to be here. Common second difference. Everybody agree there's a common second difference here? Making it what? What type, Brett? Try again. It's a common second difference. It's what type of relationship? Quadratic. Okay. All right. Now the hard part. Now we're going to actually come up with the equation. Now I'll tell you. If it's linear, I want you to try and write it in that form. If it's exponential, I want to try and write it in that form. And if it's quadratic, I want you to try and write it in that form. Now obviously, sometimes quadratics have an x term and a third term, but I'll tell you right now, the only ones I'm going to give you are the ones that would fit this basic one. Is that clear with me? Tommy, you okay? All right, now, which one is it? It's what? Quadratic. So which one am I going to use? This one. Everybody agreed? Because it's quadratic, I'm going to use that?
Yeah.
Okay, so write it down. Write down y equals ax squared, okay? And I want, I'd like Mike P to read the directions here. Read it. You need to what?
You need to find the values of A and B. Here are some tips to find them.
Keep going.
First, plug in the ordered pair x, y, stating x equals 0.
And then,
If needed, plug in another ordered pair x, y.
okay, so that's what you're going to do to find the missing values of A and maybe B. Are you ready? Okay, so start with the point what?
0.
0, 0. Okay, because that's the one that has x equals 0. Put a 0 there and a 0 here. What's 0 squared?
0.
0. What's 0 times A?
Whoa.
What's 0 times A?
0.
0. And so I don't know. That didn't give me anything, did it? Okay. All right, so now I need to pick another point instead.
2 fourths.
What do you want to, which other ordered pair you want to pick?
4.
4, 4? Fine. Put in 4, 4. Watch. No, watch what's going to happen. When I put in a 4 for y and a 4 for x, watch what's going to happen. What's 4 squared, guys? What's 4 squared?
16.
16. And then to solve for a, wouldn't I divide both sides by 16? And that would give me a equals what? 1/4. Okay? And so what I want you to do now is update this equation. Okay? So what you do now is update that equation now that I found a. So what's the equation? Y equals what?
1/4
4th x squared. All right, now how can we check it?
Plug it in.
Yeah, we can plug in all the x values in the table, make sure they give me the correct y value. Let's check a couple of them. Ready? Well, stop a minute. Does everybody see what I did here? I always start with the point 0, 0. That didn't give me the value of a because you ended up with 0 equals 0, which doesn't help me. Then I picked a different point like 4, 4. When I plugged that in, I was able to figure out what a is. So once I had a, I just wrote my equation. Y equals my a, which is 1/4, times my x squared. Is that clear?
Clear.
Yes? All right, let's check it. What about if I put in an 8 for x? What's 8 squared? If I put in an 8 for x, 64. What's 64 times 1/4? What's a fourth of 64? 16. Did it give me the right y value? Yes, it did. Let's check another one. Plug in a 2 for x. What's 2 squared? 4. What's 4 times a fourth? 1. Did it give me the right y value? Okay, you see how I'm checking my equation and I know it's right? So if this were a test, I wouldn't even have any doubt that I'm going to get this problem right by checking it. Are you with me? Okay, next one. All right, I want you guys to do this one. Go. Yep, try it. That's scary. Try it. Try it, try it, try it. Start with part A. Figure out what type of situation it is. Yeah, I already figured that out. I've had them all year. Do you need this? Were you using? Okay. Yeah, I don't think you need it today. Yep. Yeah, I don't think you need the calculators. What's that? No, you're a little bit ahead of me. I'll get there eventually. It's okay if you try it. If you don't get it, then just hold tight a minute. We'll get there. We'll get there. Yeah, go ahead, quick, okay? Yeah, pick a good time to take a break like this, all right? Not in the middle of when I'm about to show you something, right? I don't want you to miss it. Yeah, do A and B on example 4, please. A and B.
What is at? What is at?
By the way, we're finishing the chapter on Monday, and the lesson's only like a half hour, which means the last hour of class on Monday you'll be doing the practice test. And then your test is next Wednesday. Okay, that'll be the last test of the quarter.
What is app?
So it'll be the last chance for you to help your grade.
What is app? Alright.
You'll figure it out.
So do I just do m times -3? And then times 0?
Do whatever, yeah, just ignore it for right now. Put it there and put in the values for x and y. Don't worry about it.
I still have to finish the rest of that one test.
Yeah, good idea. So come in soon. Okay, so start by plugging the point 0, -3. Yeah, that'll...
Wait, so I do -3 for y.
Just add m.
What's m times 0? Okay, and put a 0 there and keep going.
What's 0 plus b?
B. So you get b equals some value. You got b. Okay, now you got b. Now you need to find the other variable. Okay, so that gives you b equals -3, yeah. Okay, now you need to find m, right? So pick another point. Okay, go with it. Yeah, hold on, people are struggling. All right, guys, too many of you are struggling. We better do this one more together. Shh. Guys, how do you get from here to here, or here to here, or here to here? Each time you're what? Adding 1. Okay, so as long as there's a constant change in x, shh, it's safe to look for a pattern with the y's. Is there a pattern to go from here to here, here to here? What is it? Each time you're what? Adding 8. Okay, watch. Watch, watch, watch. Ready? Okay, so obviously there's a what? Common what? First difference, yes?
Yeah.
So, with that in mind, what type is it?
Linear.
Linear. All right, now watch, guys, please. Watch. You don't want to miss this. Okay, so since it's linear, I'm definitely going to go with this equation, yes? Everybody agree? Okay, and so in this case, we need not A and B, but we need what? M and what? M and what? B instead of A and B. Okay, so this time we need M and B instead of A and B. Are you with me? Yes? All right, so to find them, there's a couple ways to do it. To stay consistent with what I taught you in the last example, what do we start with? The point, what? That has what in it? 0? Shh. Jack, please. So I'm going to put in the point 0, -3 by putting a -3 there and putting a 0 there. Okay, are you ready to simplify, guys? What's 0 times m?
0.
0. Shh. And clearly that gives me b is what? Jack. Everybody agree that gives me b equals -3 if I solve that for b? You see that? Okay, now pick another point. And by the way, since you know what b is, you might as well put that in. Okay, and then pick another point. What other point you want to pick?
1, 5.
1, 5, that's fine. Fine, pick 1, 5. Stick it in here. And what does that give me here? Gives me that, and if I add 3, I get m equals what? M equals 8. Okay, so now that you have m and b, what's your equation? So what's the equation now that you have m and b?
8x minus
Y equals
8x.
mx plus b,
What?
right?
You said mx, but wrote 8x.
Right, because m is my 8. Everybody agree that the equation y equals mx plus b is that? All right, now wait a minute. Wouldn't there be an easier way to find that?
Yeah.
Yeah. Didn't we learn first semester that b is the y-intercept, 0 comma something? So didn't you already have that in the table, that there's your b right there?
Yeah.
And then how do you find slope? Change in y over change in x. What is the change in y? 8. What's the change in x? 1. What's 8 over 1? 8.
Why did we do this?
Because I wanted to stay consistent with the way I did it the first example.
You can't just do that to us and then tell
Well,
us
no.
it's quick.
there's nothing wrong with finding multiple ways to do things. That's good that you find multiple ways. Got it?
Yeah.
Understand or not, guys? Yes? Okay, so, but again, that only works with a line. That's why I didn't want to, I didn't want to start with that method because that only works when it's linear. But this way will always work. If you plug in the point with 0 and then plug in another point if you need to, okay, that way will always work. All right.
It won't work if it's exponential.
Yes, it will.
It's time.
It will. Try it. Give it a shot. Go.
You're right.
Try it. It'll work. You just got to give it a chance. You got to be a risk taker.
No, I'm saying like you know how you can like look at the side.
Oh, yeah, the M and B won't work.
Yeah,
Right.
that's what
That
I'm
won't
trying
work.
to-
Okay. Okay. I thought you meant the other method won't work.
What's A times B?
By the way, when you have a times b to the x, you can't do the a times b until last because you got to do the b to the x first. Right, according to PEMDAS? Yeah, that's right. I already looked at it.
So what's B?
Just so you know, you got to follow PEMDAS when you're doing that.
What's B to the 6th power times A?
What?
Why?
What do
Did you mix them up?
He's using a different.
Yeah, I think you mixed up the x and the y.
What?
X is these. You put the y there. I
Oh,
think you
well, the
mixed.
first one.
I think you mixed them up. Yeah, 6 should not be going in for x. 6 should be going in for y. Right?
I agree.
Okay. Okay, try it.
Right.
Try and get the equation now, guys. You got to experience this on your own. You can't wait for me. Try it. Go with it, Tommy. Go with it. What's that? But it's not linear. You multiply each time, it's what? Okay, first of all, b to the 0 is not 0, it's 1. You guys, anything to the 0 power is 1, not 0. That's why you had a problem there, right? Anything raised to the 0 power is 1. Zach, please, heads up. You got to try it, please. It's quadratic. It's not quadratic. It's
1A. It is
it's common ratio. It's what? Exponential. So fix that, and then I want to see you write that down there and try and figure out what A and B are. Yep. Wait, why are you putting in 6 there?
That's the reducer B, right?
Okay. Yep. No, it's not. It's not. It's not. No. You guys, the B here is not the same as B in a linear situation. Please don't think that these B's are the same. B is only the y-intercept if it's linear. So don't think like that. B is only the y-intercept if it's linear. So don't think of that. Okay, put your x in there. It's not like that. It should be b is outside. It's 8 times b to the x.
So I got a different incident trigger. I don't know.
Well, the problem is you shouldn't be putting anything in for b until after you found it another way. B is not 6. That's where you made a mistake. B that would only be b if this was linear. This is not linear.
Oh, okay.
All right, so you guys, b is only the y-intercept if it's linear. This is not linear because if you look at the table, each time here you're going up by what? 1, which means simply that you can look for a pattern with the y's. how do you get from here to here, here to here? What's the pattern? Each time you're what? Multiplying by 3, which means there's a common ratio, yes? Of 3, yes? Got it? Yes or no?
Yes.
So therefore, it's what type? Quadratic, linear, exponential. Which one? Quick, quick, quick. What is it? Exponential. All right, now watch this. All right, so clearly then, since it's exponential, we're going to go with this one here, aren't we? Yes? Okay, so write it down. So clearly we need to find A and B, right? Okay, so the first thing you want to do is start with the point that has 0 in it and put it in. Okay, so what am I going to put in for y? 6. What am I going to put in for x? 0. Okay. What's b to the 0 power? Well, anything to the 0 power is what? No.
No,
It's 1.
Yeah.
Anything to the 0 power is 1. So that turns into a 1, which means clearly a is what? A is what? 6. And so I want you to update this equation now. Update it. Yes? And so when you update it with the a value, you get y equals 6 times what? B to the x. And so now all you got to do is find b and you'll be done, right? And so to find b, you pick another point. Which other point you want to pick?
118.
118, that's fine. Doesn't really matter. Let's pick that one. Okay, here we go. Yep. Put 18 there. Put a 1 there. Right? And what do you guys think? Divide by what? 6. And you get what? B equals what? 3. Okay, so I want you to update this again. So once you update it, you get what? Y equals 6 times what? 3 raised to the what? X power? Please don't make that 18 to the x power. Why is that wrong? Why would it be wrong to make it 18 to the x power? Because then you'd be doing what? Multiplication before the what? Exponent, which is wrong. According to PEMDAS, you're supposed to do exponents before the multiplication by the 6. Do you understand? By the way, there's an easier way to do this. We wrote these equations first semester. What do you notice? What's the 6? The 6 is your what? Your y-intercept. What's the 3? The 3 is your what? Common ratio. So if you want to use it that way on the test, I'm fine with that. Again, the easier way is just to know that the A is your what? Your A was 6, so your A is your what? Your y-intercept, and your B is your what? The common ratio. Got it? I mean, that's really the way we did it first semester. You probably just don't remember, and so I didn't want to go back to that until after we saw it another way first. But it's up to you how you want to figure this out on the test. Is that clear? Yes?
Yeah.
Okay, we have one more problem, and we're done. This is a challenging problem, so do it. Go. Okay, so basically make a table and then graph the two and then answer the question. Go, 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 go. Focus. Focus. Last problem. Do it. And again, don't use your calculator. I didn't give you anything hard enough today to where you would need your calculator. You can do it all on paper. Yeah, but it says for what values of x, not f of x. Please write a brief sentence on the explanation. Or you can explain it verbally to your partners. It's up to you. You can either write it in sentence form or you can explain it to your partners. But you want to explain what's happening in the table and the graph to answer the question. And it would help to use different colors when you graph the two functions. It would help.
Two times what? What's 2 times 2?
How's it going?
Can I get another copy of that? So I just
All of it? Yeah. Your brother's right here. He's doing a good job, too. Coming. Yes.
Why are your homework assignments always sad?
They're always what?
Sad.
What does that mean?
It's a joke.
I don't get it.
Why are your homework assignments always sad?
I don't know. I give
Because
up.
they have a lot of problems.
Ah, very good. See ya. Okay. That's very good. Your joke's permanently part of my recorded lesson. That's true. Yeah, that's true. Yeah. Yeah, again, I mean, stuff looks easy when we're doing it, in class together and we do it multiple times, but then when you go home and try it on your own, it might not come back to you. So you're going to have to look at your notes, guys, to remember what we did if it doesn't come back to you right away. Okay, now graph them.
That's what I was saying. I don't think we're supposed to graph that.
Yeah, it does say to graph, yes. Both. Both. No, the 532 is off the graph, but you can plot all the other points, and that's enough. Yeah, you guys, I know you can't plot the 532, but you can plot everything else. Got it, Steve? He's showing you. He's showing you. Make sure you answer the question after you've made the table and the graph. What was?
Tech design. We just build stuff and we solve problems.
In what, in middle school? Where?
Last semester.
Oh, last semester.
I'm pretty sure I just broke my elbow.
f of x and g of x is basically
Okay, I agree with greater than, but not equal to, because at 3 they're equal.
Yeah.
So f of x is not greater than g of x there, they're equal, so
But
take the equal sign
yeah, they
out.
are equal. So that's why.
Yeah, but it says,
if x is greater than.
when is that greater than that?
Oh, so I can't have an equal.
Right. Make sense?
Yeah.
Okay. Connect them?
I
Got
think
the
I'm doing it all right. I don't know if I'm doing.
No, you're not. You're fine. Oh, wait a minute. You're just,
I don't understand this problem.
look, you're putting a 0 there. What's 2 to the 0?
Oh, I'm supposed to. Oh,
1.
never mind.
Okay, be careful. When I put a 0 in there, what's 2 to the 0? It's 1. Yeah. Haagen-Dazs is a really good ice cream.
Doesn't know what it is.
It's very unhealthy, but very
And
good.
Ben and Jerry's is real, right?
Mm-hmm.
What are you talking about? How many more sections?
What?
How many more sections till it's done?
One, and it's only like a half-hour lesson next time. So next time, on Monday, you guys, I'm going to give you a new lesson for about only a half hour, and then the last hour of class will be practice test, and then the time after that will be your test. So next Wednesday is your test. All right, ready, guys? Okay. You can, Tommy, ready? Okay, so here we go. Okay, to get these values, I'm going to put into 0 there. Everybody, what's 2 to the 0 power? 1. Okay, then what happens when I put a 1 in there? What's 2 to the first power? 2. What happens when I put a 2 in for x? What's 2 squared? 4. What about a 3? What's 2 cubed? 8. What's 2 to the 4th? What's 2 to the 5th? 32. All right, any questions there? Okay. Shh. Now I'm going to find these values, which I'll use maybe green. Shh. Okay, so if I put a 0 there, what's 2 times 0? What's 2 times 0? Come on, guys. 0 plus 2 is 2. Okay, if I put a 2 there, 2 times 2 is 4, plus 2 is 6. If I put a, I'm sorry, I skipped this. What happens when I put a 1 in? I get a what? 2 times 1, which is 2, plus 2 is 4. What if I put a 3 in? 2 times 3 is 6, plus 2 is 8. What's the next one? And, okay. All right, now here's what I'm going to do. I'm going to plot these ordered pairs to draw the graphs of the functions f of x and g of x. So I'm just going to plot those points for f of x. Are you ready? 0, comma 1, which is here. 1, comma 2, which is here. And 2, comma 4, which is here. 3, comma 8, which is here. 4, comma 16, which is up here. And then 532 is off the graph. So I'm just going to use those values there. Okay, now, what happened? Yeah, I know. I don't know what happened here. I messed with my camera. Can't win.
It looks fine.
All right, it's fine. Okay. All right, ready, guys? And so when I connect them, obviously this should look familiar to you. That's what type of a curve? What? Exponential, right? And by the way, this keeps going down. It gets closer and closer to the x-axis, but never touches, right? Okay. Then, please, guys, shh, Mike. For g of x, I'm going to graph the x values along with those y values. So 0, comma what? 2, that's here. 1, comma 4, that's here. 2, comma 6, that's here, and so on, right? Okay. 3, comma 8, 4, comma 10, and 5, comma 12. All right, so clearly that's a line, isn't it? All right, now watch, Brent, watch. You can't miss this. At the end of the hour, remind me, not in the middle of the lesson. Okay, watch, guys. Shh. Guys, shh. All right, so now ready to answer the question? Remember, the green one is f of x, the red one is, I'm sorry, it's the other way around. The red one is f of x, the green one is what? G of x. Okay, so the question is when is f of x greater than g of x? That's the question. When what? For what x values? When x is what? Greater than what? 3. You can see it right here, right? Don't they have the same y value at 3? But after that, the exponential one really takes off, doesn't it? Doesn't it? You see how these y values are bigger than this? All right, now if you don't see it with the graph, let me show you. Let me show you in the table. Are you ready? Shh. When x is 0, what's greater, f of x or g of x? Come on.
G of x.
G of x. When x is 1, what's greater? G of x. When x is 2, what's greater? G of x. When x is 3, what? Neither of them. It's right, they're equal. What about when x is 4? What's greater, f of x or g of x? F of x. How about when x is 5? What's greater, f of x or g of x? F of x. So you can clearly see at x equals 3, they are equal. But after that, what do you think is going to happen? F of x is always going to be what? Bigger? Can you see that? Yes? So that's my answer. F of x will be greater than g of x as soon as x goes beyond 3. Do you see that? Okay, and so you're going to have the first couple problems in your homework are exactly like this. So take a break till 12:25, and then I want you starting that homework. Thank you.